Okay, so right now our task for the day is to expand logarithmic expressions. Okay, so where's my pen? I can't find it. Okay, here we go. Okay, so on the upper left hand corner, you can see some formulas in here, some guidelines. So if you have a log of a product, when you expand them, they both get the log base, but then you add them. So every time you have something that's getting multiplied, they get separated by an addition. Now if there is a denominator, that's going to get subtracted, so that's why you have a subtraction here. And then of course if you have an exponent, then you can put that in front of your log. So these are ways to expand your expression. So let's do something pretty basic first, not starting with our first problem. So let's say you have log 3, okay, x y z over m. Okay, so as you can see, this is a fraction, right? So you have one, two, three. You have three expressions. In fact, I'm gonna add a 5 in there. Okay, so log 3 of 5xyz all over m. So as you can see in your numerator, these you have four factors there. So each one of those gets a log 3, and then they get separated by a plus sign. The m though is in the denominator, so it also gets separated, but in front of it will be a minus sign. So let's try that. So I'm going to do a log 3, 5. That's the first one. And then x is also a numerator, so I'm going to say plus log 3 x, that's done, plus log 3 y plus log 3 z. Okay, so that's all four on the numerator. But then I have a denominator, so instead of a plus, I'm going to have a minus log 3 m. Okay, that's simple, really. Okay, now another example is if we say log no base, that means it's base 10, square root of x. Okay, so we have not really done something like this. So if you have a radical, you have to change this radical into an exponential form first. Okay, so that means this x right here has an exponent of 1, um, hidden exponent because it's a 1, and then you're taking the square root, so therefore the index here is 2. So that x, the square root of x in itself, 1, 2, this can be changed into or converted into an exponential expression, x to the power of 1 over 2. So that 1 there over 2. If you have, let's say, fourth root of x to the fifth, then this could be changed into x that to the power of 5 divided by 4. So that index. So that's how you change a radical expression to an exponential expression. So going back to this problem, we can change this one into a log of x to the power of 1/2. Now this is not expanded because you have an exponent, right? So using part 3, this number 3 formula there, you can put that exponent in front, and so that could be 1/2 log of x. So that's the expanded form. Okay, so I think we're ready. Let's answer our questions now. Okay, so let me erase these things first. All right, so number one, what they have there, look at that. That's also a fraction. And you also have a radical. So if I have a radical, I would convert it into exponential first before I even expand them. Okay, unless you can do it all directly, then that would be great, right? But for now, I'm just gonna change this one into this square root of c. Okay, so I'm gonna rewrite this as log of a over b squared c to the power of 1/2. Okay, because the square root of c is the same as exponent of 1/2. Now your a here is a numerator, and then you have two denominators, so now we can expand them as log of a, but then the b squared, that is the denominator, so it'll be a just minus a minus log of b squared. C is also a denominator, then that will be minus log of c to the power of 1/2. Now, this is almost done, except that you have exponents. Now, remember, if you have exponents, you need to do the third formula. So this is going to just be log 3 log a, and then this 2 will go in front. That will be minus 2 log b e minus, and then another exponent, 1 half log c. All right, so this is your fully expanded logarithmic expression equivalent to letter A. Okay. All right, so now let's try number letter B. Okay, so if you want, you can pause this and try number two first on your own, and then you can compare your answers with mine. Okay, so number two, you have log of x y squared z to the power of 3. Well, none of them is a denominator. They're all numerators basically. So therefore, they should just be separated by a plus sign. So log of x, that's the first one, plus log of y squared plus log of c cubed. Okay, and then lastly, we get rid of the exponent. So this is just going to be log x. This 2 will go in front of your log, plus 2 log of y, and that 3 will go in front of your log, plus 3 log of z. So that's the fully expanded number 2. Okay, all right, so let's try number three. Again, pause it. Try number three first on your own and see if we have the same answers. Okay, so let's try that. Okay, so we have ln of ln of ex cube. All right, so you have ln instead of log, that's just ln. So now you have two factors, so you can say ln e, well, these are multiplied, plus ln of x cube. All right, now however, ln e, you can actually simplify that because ln e is just equal to 1. Remember, the exponent of this e is 1, so this ln and that e will cancel out. So therefore, all of these is just equal to 1. Plus, and then you have this exponent will go in front of your ln. So 3 ln x. So this is your final expanded version. All right, so let's try number 4. I think number 4 you should be able to do. Okay, so again, pause it, try it, and then we will compare. Okay, so you have log of 2 x y over c cube z cube. Okay, so now you have two numerators, so that will be a plus, that's a plus, this is going to be a minus, right? So you have log base 2 x plus log base 2 y minus log base 2 z cube. Okay, now lastly, you have that exponent, you want to get rid of that, so log 2x plus log 2y, and that 3 will go, if I can move it, okay, like 3 will go in front of your log, minus 3 log 2z. So this is the fully expanded version. Okay, so again, this is your challenge question. I'd be curious to see what your answers are gonna be. Okay, so last question, and your answers could go to the comment section below. All right, so let's try something simple, something simple. Okay. All right, so let's try log 3 2xy cube over 5 m. Okay, so try, oops, I don't know what happened there. Okay, so try that. In fact, I'm gonna just, I know in the comment we could probably not write the, we could probably not write the log 3. So I'm gonna delete the remove this 3. Okay, so it's just now it's just log of that. Okay, so tell me what's your answer and looking forward to them.